Welcome to CE 2100 Springer 1. In this third lecture on construction engineering and management, we will focus on the work breakdown structure and cost estimation. This lecture has two learning objectives. First, to develop a work breakdown structure, or WBS, where you'll learn how to use this method to identify construction work packages. The second objective is to understand the different types of cost estimates. Let's begin with the first learning objective. Before learning how to use a WBS, it's important to understand what it is. According to PM Bach, a WBS is defined as a deliverable-oriented hierarchical decomposition of the work to be executed by the project team to accomplish the project objectives and create the required deliverables. While the Association of Project Management offers a slightly different, more concise definition, a WBS is a hierarchical structure of things that the project will create or outcomes it will deliver. Although the wording differs, both definitions describe WBS as a hierarchical structure of the work required to complete the project. This is an example of a WBS for a construction project. The hierarchy consists of three tiers, each with defined work packages at varying levels of detail. The upper level is often referred to as the parent, while items in the lower levels are called children. The highest level represents all the work required for the project. The second level divides the project into major phases, while the third level further breaks down those phases into specific work packages. You can use a tree structure, like the previous example, to develop a WBS. Alternatively, you can use an outline structure, as shown in the example on the right. A tree structure visually represents hierarchical relationships with branching nodes, making it ideal for illustrating complex connections between elements. In contrast, an outline structure organizes information in a linear, text-based format, which is simpler and more compact, making it suitable for documents and reports. The lowest level items in the WBS are called work packages. These are items that cannot be further subdivided into smaller components. Work packages are assigned to an individual or a work crew and should have a specific timeline, budget, resource allocation, and acceptance criteria. These criteria are used for approval upon completion. Please note that there are no strict rules regarding when to stop breaking down a WBS or how many levels are necessary. Key factors in deciding when to stop include achieving manageability, ensuring the completeness of deliverables, providing an appropriate level of detail, maintaining clarity of understanding, and aligning with project planning tools. For example, if you cannot assign a specific individual or crew to complete a certain work package, it is not considered a valid work package. In that case, you need to further break it down into separate packages. If you are a novice engineer without experience, but are tasked with developing a project WBS, where should you begin? Well, you should keep in mind that creating a WBS is more of an art than a science, and there is no single correct approach. Developing a good WBS requires significant experience. You can start by looking for templates or reviewing the WBS from similar projects. Watching videos on how a parking lot is constructed can also help you understand the necessary tasks. Most importantly, be sure to review the project drawings and requirements, as these will guide you in identifying the required deliverables for the project. After developing a WBS, please keep the following three rules in mind to verify its accuracy. First, a WBS is outcome-focused. It should emphasize the results of the work, such as deliverables, rather than the activities or methods used to achieve them. Every element should be described using nouns rather than verbs. Second, each child element must have only one hierarchical relationship with its parent. Additionally, each parent must have at least two child elements. Third, the total effort required for the child elements should equal 100% of the parent level. Developing a WBS offers multiple benefits. First, it helps fully define the project scope by explicitly listing every required deliverable. Additionally, it serves as an input for many project planning activities, such as organizing work. This structure clarifies team members' specific roles and responsibilities within the project. A WBS also enables more accurate cost estimation and budgeting. Each work package can be evaluated for its cost implications, leading to a more precise overall project budget. Furthermore, a WBS provides the foundation for creating project schedules. By breaking the project down into smaller tasks, It becomes easier to estimate durations, sequence activities, and identify dependencies. When using a WBS to manage work, we often merge it with an organizational breakdown structure, OBS. Combining the WBS and OBS provides a comprehensive view of the project, clarifying how work packages align with organizational roles and responsibilities. This integration helps ensure that everyone understands their tasks and how they contribute to the project's objectives. When you merge the WBS with the OBS, you create a table called Project Responsibility Assignment Matrix, or RAM. This is an excellent project management tool that clarifies roles and responsibilities within a project team. It ensures that every task or deliverable is assigned to a specific individual or group, thereby enhancing accountability and communication. It is typically structured as a matrix, with columns representing specific tasks, deliverables, or work packages from the WBS, and rows representing team members, roles, or departments involved in the project. Alternatively, you can arrange tasks in the rows and individuals in the columns. Remember that each task may be assigned to multiple personnel with different roles, such as performing the work, reviewing, consulting, or supervising. Therefore, it's best to clarify each role in the RAM matrix. Now let's move on to the second objective of this video, where we will explore the different types of cost estimates. This image illustrates the three main types of cost estimates: conceptual estimates, preliminary estimates, and detailed estimates. From left to right, the estimates become progressively more detailed and accurate. Conceptual cost estimates are high-level assessments made during the early stages of a project, often before the completion of schematic designs. These estimates offer a rough approximation of the total cost, assisting stakeholders in feasibility analysis, estimating the initial budget, deciding whether to proceed with the project, or comparing different projects. Because they are based on minimal design information, their accuracy is relatively low. Typically, conceptual costs are estimated using unit costs, such as the dollar amount per square foot of similar projects. Preliminary cost estimates are more detailed than conceptual estimates and are developed during the early planning phases, typically after some initial design work has been completed, but before detailed engineering and construction plans are available. They serve as refined versions of conceptual estimates, used to validate project feasibility, prepare an early budget, and secure funding. While preliminary estimates provide a more accurate view of project costs compared to conceptual estimates, they are still approximate and may change as additional information is gathered. Like conceptual estimates, preliminary estimates are usually based on the dollar amount per square foot of similar projects. However, at this stage, the estimates are generally more accurate due to a better understanding of the project scope. Another type of cost estimate is the detailed cost estimate, which is created during the later stages of planning, usually after the design and engineering work has been completed. These estimates rely on a thorough understanding of the project scope, including detailed drawings, specifications, material quantities, and other precise information. They serve as the foundation for final budgeting, procurement, and financial planning for the project. Detailed estimates are highly accurate compared to other types of estimates because they rely on a complete design. They involve thorough calculations of direct costs, such as materials, labor, and equipment, as well as indirect overhead costs, including office space, utilities, and administrative staff salaries. It's important to remember that project costs are influenced by many factors. Beyond scope and size, other key considerations include inflation, weather, soil conditions, location, and management efficiency. For instance, two similar projects may have different costs if one is built in a rural area and the other in an urban area. Last but not least on this list, don't forget to include a contingency, which is an additional budget set aside to cover potential unexpected expenses or risks that may arise during the project. This financial buffer helps account for uncertainties, such as changes in project scope, unforeseen conditions, or other unpredictable events that could impact costs. Let's assume you're tasked with defining the project scope using a WBS and calculating the conceptual estimate for a parking lot project. For the cost estimate, you can use the unit cost per square foot based on similar projects, which typically ranges from $15 to $22 per square foot. By multiplying this range by the total area, say 10,000 square feet, the estimate would be between $150,000 and $220,000. To determine the required budget, you would add a contingency to the cost estimate. Contingency is often calculated as a percentage of the estimated cost, and for a conceptual estimate, it's usually around 30%. This buffer helps account for potential uncertainties or risks. For the WBS, work packages might include tasks such as design, surveying, clearing, grading, and installing drainage systems. If drawings are available, review them and consider watching videos on parking lot construction to gain a clearer understanding of other work packages that should be included in the WBS. In summary, this video covered the definition of a work breakdown structure, WBS, how to develop one, and its various uses. WBS is essential for defining the project scope and supporting project planning, including cost estimation and scheduling. You also learned how to create a responsibility assignment matrix, RAM. Finally, we discussed the three types of cost estimates: conceptual, preliminary, and detailed, with detailed estimates being the most accurate due to their use of precise design details. This concludes the video. Goodbye for now, take care, and see you in the next one.